Hi guys, welcome back to Coffee's Classroom. Today we're going to do some third grade addition. We are going to start off with the expanded form. So when we do expanded form, we have to break our numbers into expanded form. Imagine that. So we're going to think about our place value. When I have 780, I want to break that into 700 plus 80. I can also write plus 0 ones because we don't have any ones. We have 8 tens and 7 hundreds. Then I want to break my second number into its place value. So we have 200 plus 9 tens, which we know is 90, and we have 1 1. So now I can add down. 0 plus 1 is 1. Bring down my plus sign. Now we need to do 0 plus 0, we know is 0, but 8 plus 9. So if you need to count on your hands, you totally can. That's fine. In third grade, we can do that. So we would start with our bigger number. We start with 9 and we go up 8. So 9, 10, 11, 12, 13, 14, 15, 16, 17. So I would write 17, but we said we need to bring down our 0. So this means we need to regroup. My third graders know we can't have more than 10 tens. But before we regroup, we're going to go ahead and add our hundreds. So 7 plus 2, we do 7, 8, 9. So we know it's 900. But we know, like I said, we cannot have 17 tens. So we need to regroup. So I'm going to take one of my hundreds and I'm going to bring it over to the 900. So 900 plus 100 is 1,000. So now we have 1,000. We brought over our 1, so we no longer have it anymore. So now I can add 70 plus 1. So we brought our 1 over here, and now we need to put our number back into one number. So 1,000, we don't have any hundreds, we have 7 tens, and we have 1 1, gives us 1,071. So we have 1,071. We just need to rewrite it back in our regular number. So in this one, we had to regroup. That's okay, we can do that. My third graders know how to regroup. We just had 170. We take 100, add it to the hundreds, and now I'm left with 70. That is expanded form. So the next type of problem we can do, it's still addition, but this time we're going to use partial sums. Get that out of the way. Now we're going to use partial sums. On this problem, you might notice that our equal sign is in front of the problem. That's okay. It can be on either end. So we have 4,836 plus 1,165. In partial sums, it's going to look a little different. I'm going to add my place values first. So in this problem, it's actually easier to stack my numbers. So I'm going to rewrite 1,165 below, and now I'm just going to add down. On partial sums, we're actually going to add our biggest numbers first. So normally we would start in the ones column, but this time we're going to start in our thousands column. So we're only going to add the thousands. We're going to pretend like these are all zeros. So 4,000 plus 1,000 is 5,000. Then we're going to come over to our hundreds column. 800 plus 100 is 900. Then I have 30 plus 60, we get 90, and 5 plus 6, we get 11. We have 11 ones. We're just going to write it like normal. Then I'm going to write my line, and I'm just going to add down. 0 plus 0 plus 0 plus 1 is 1. 0 plus 0 plus 9 plus 1 is 10. I'm just going to bring over my 1. 9 plus 1 is 10 again, and 5 plus 1 is 6. So the answer to this problem is 6,001. So what I did here that's different from our standard algorithm is I started with my thousands and I just pretended like everything else was zeros. So we get 4 plus 1 is 5, then 8 plus 1 is 9, 3 plus 6 is 9, and 6 plus 5 is 11. Then I just add down. So we can do it that way. These are all different methods on adding, so as long as you're adding, it doesn't matter what method you use, you'll get the same number, or the same answer. So now we're going to do the standard algorithm. This is what we're used to seeing. So this way, there's no extra numbers, we're just going to add like normal. So we're going to do 6 plus 7 is 13. I'm going to write my 3. I need to carry my 1 because we're regrouping. I put my tens in the 10 place. So now we have 3 plus 2, which is 5, plus 1 is 6. 7 plus 1 is 8. And then 8 plus 1 is 9. So now we have 9,863 as our answer. If you notice, the directions for this problem are find the sum. My third graders know that the sum is just the answer to an addition problem. So if it says find the sum, if this wasn't here, you would still know to add because it tells you to find the sum, and the sum always means addition. And so that's the standard algorithm. This is what we typically see. And sometimes there's going to be some word problems. That's okay. We just have to read it carefully and figure out what it's asking us to do. So in this one it says, Jack went up the hill and fetched 319 pails of water. Jill went up the hill and fetched 467 pails of water. How many did they fetch in all? So we need to figure out what it's asking us. Well, the question says, how many did they fetch in all? That tells us we need to add them together because we need to see how many they have all together. So if we know that Jack fetched 319 pails and Jill went up and fetched 467, we know that we're adding them together. We just need to add our numbers. So we have 319. We also have 467. I want you to notice how I wrote this. I started with my numbers first, then I drew my line, and then I drew my plus sign. Sometimes I see students doing this. 319 plus 467. Because they started with their plus sign, now their numbers are not lined up very good, and it's hard to add. That's not what we want. Always write your numbers first, and then your plus sign off to the side. That's going to make sure your ones, tens, and hundreds are lined up exactly. So now we can just do our standard algorithm. 9 plus 7, like I said before, if you need to use your hands, that's okay. When I use my hands to count, I start with the bigger number in my head and I just count up. So we start with 9, 10, 11, 12, 13, 14, 15, 16. So 9 plus 7 is 16. Now we have 6 plus 1 is 7, plus 1 is 8, and 3 plus 4 is 7. So they fetch 786 pails in all. And that's our answer. Easy peasy lemon squeezy. You guys totally got this, as long as we make sure we line up our answers. This one looks a little different, but we can still figure it out. It tells us to find the sum, so we know we're adding. And our first number is 15 hundreds, 14 ones, 7 tens, and 1,000. That's our first number. But we can figure out what that means. I like to start with the biggest number. So I see 1,000 and I know that's the biggest. So I'm going to write 1,000. And I like to cross it out so that I know I already used it. So 1,000 plus my next biggest number, we have tens, ones, and hundreds, is 15 hundreds. Well, I know that 15 hundreds is actually 150, because when we have hundreds, we always add a 0 That makes it 150. So we used our hundreds. Now I have 14 ones and 7 tens. Well, 7 tens is bigger, and I know 7 tens is 70. And then we have 14 ones left. Well, I know I can't have 14 ones because there's a group of 10 in there. So I have to move it over. So now I have 1 over here, and it is no longer there. So now I have 4 ones, 8 tens, 150, plus 1,000. So we're going to write our number. 1,000. We can't have, oh, we messed up. I messed up. Teachers do that sometimes. We need to regroup over here, right? So what we're going to do, let's rewrite this so that we make it easier on ourselves. I like to do it where I stack my numbers. So 150 plus 70 plus 14. So I just rewrote all of these down here. That way we don't get confused because writing all these arrows is going to be too much. So 0 plus 0 plus 0 plus 4 is 4. Now we have 5 plus 7 plus 1. So we could do 5 plus 7 plus 1. We could do 7 plus 1 plus 5. However you want to do that, I like to do it on my hands so that I can keep track. So when I count on my hands, like I said, I always start with the biggest number, which is 7. We're going to count up 5. So 7, 8, 9, 10, 11, 12. And then we have one more. So it's 13. 1 plus 1 is 2. And then we bring down our 1. So our first number is actually 1, 2, 3, 4. Look at that. 1,234. That's just one digit. And now I need to figure out what this is. So we have 3 thousands. It's the same thing. Let's do it in a different color. So for our second number, we'll do it in red. We have 3,000. We have 30 tens, which is 300. And we have 6 ones. We used our thousands, we used our tens, we used our ones. So this one, we might not need to write it like this because we can figure out that 3,000 plus 300 plus 6 is 3,306. So now what we can do is rewrite all of these numbers so that we can add them together. So we know this is 3,306. So in a different color, let's choose blue. We're going to rewrite both of these numbers so we can add them together. 3,306, that's just from right there, plus 1,234. And now I can add. 6 plus 4 is 10. I write my 0. My 1 goes up here. So now 3 plus 1 is 4. 3 plus 2 is 5. And 3 plus 1 is 4. So our answer is 4,540. So 1,500s, 14 ones, 7 tens, 1,000, plus 30 tens, 6 ones, and 3,000s is 4,540. So we started out writing it like this and we decided that's a little too complicated. So sometimes it's okay to try one method and then do it a different way, whatever works best for us. I thought that writing it this way might be a little easier so I can line up all of my numbers, because when our value places are lined up, it's much easier to add than to see it this way written out. That's kind of hard to do in your head, but when we see zeros, it's much easier to add this way. For this one, the numbers was simple, so we didn't need to rewrite it a different way. But as long as we realize that this top line was one number and the bottom line is one number, we still have to add them together. So this kind of problem has a couple of steps. We have to figure out the first digit, figure out the second digit, and then add them together. That's totally doable. I know it seems a little confusing, but you guys got this. And then lastly, we have one more type of problem. So this one asks, which digit does the box represent? We already have an answer, But now we're trying to figure out what goes right here. So we have to figure out 8 plus what equals 7. So we're going to start by working the problem. That's the easiest way to figure it out. So we know 3 plus 1 is 4. We already had that. 5 plus 8, it's not 3, it's 13. So our 1 has to go at the top. So now 8 plus 1 is 9, but we need to get to 7. So we need to figure out what will get us a 7 down here. So if we do, we're just going to call this 9 because we know 8 plus 1 is 9. 9 plus 1 is 10. 9 plus 2, so this wouldn't be a 0. So we're going to try 9 plus 2 is 11. That wouldn't work. 9 plus 3 is 12. That wouldn't work. It would give us a 2 down here. So we need to figure out what goes in this box. So let's keep going. 9 plus 3 would give us 12. 9 plus 4 would give us 13. 9 plus 5, let's see, 9, 10, 11, 12, 13, 14 wouldn't work. 9 plus 6 is just one more. That would get us 15. 9 plus 7, we could try that. 9, 10, 11, 12, 13, 14, 15, 16. We only need one more. So we need to try 8. So 8 plus 8, we know our doubles. 8 plus 8 is 16, plus 1 is 17. So if I put an 8 here, 8 plus 8 is 16, plus 1 is 17. So now we need to make sure that 5 plus 2 plus 1 is 8. 5, 6, 7, 8. That works. So we just needed to trial and error to see what goes in our box. If it's easier to write some stuff out to the side, you could definitely do that too. So I was keeping track in my head, but if you wanted to do, we're going to call this 9 again. If you wanted to do 9 plus 1 equals 10, that wouldn't work. 9 plus 2 equals 11. We know that wouldn't work because we want this number on the side to be a 7. You could just keep trying. So we would just have to trial and error until we got to 17. We see a 7. We wanted that.